So, what architecture we talking about? It's pretty standard. You have your API gateway, Lambda, and some business logic behind it, and maybe some static content. So let's just focus on the interaction between API gateway and the Lambda. In order for them to interact, they need to be allowed to talk to each other. And you can do it in two ways. One way is to attach so-called credentials to API gateway. And the second way is not to attach anything to gateway, but to attach a resource policy to the Lambda. I'm here. Okay, I lost audio. Audio is back, I think. Okay. So, as we all know, Lambda has a cold start, and there is just a chart of cold starts. But if we don't want to have a cold start, we shall use provisional concurrency. And also, as we all know, that if we need to access a database, then we should put a Lambda in a VPC. And the main point here is that deploying provisioned concurrency Lambda in a VPC, it will take much more time than deploying just a Lambda without all those things. So we found out, and a disclaimer, this was done actually some time ago. I don't know if the situation changed recently. So some time ago, we discovered that if you have a Lambda with policy, a resource policy, and you just want to replace it with second version, your Lambda connection to API gateway is a permission. It goes away for a moment. And as VPC-based Lambdas with provisioned concurrency takes a while, like a few minutes to redeploy, then you are offline for that time. So how do we self-DDoS ourselves? Consider this scenario. We have a client. It's a very nice client. When it gets an error from API gateway, it retries. Nothing too special, no bugs, just once in 1 or few seconds and a bunch of times it retries if it gets no 200 answer. And then we have our Lambda and maybe some application logic behind the Lambda, some application, I don't know, maybe legacy, and it's like a slowish application. It talks to database. So we start to redeploy our Lambda, and the connection is broken. This is, I remind, this is for resource policy permission case. So after a bunch of seconds, you have more clients discover that your system is offline. So they all politely start to retry in 1 second or so. But you multiply your clients. They're not talking in order to the system, but they talk all at the same time. So finally, we deploy Lambda version 2, and the connection restores. And our Lambda is perfect. It scales very well. So application gets a hard hit, a lot of traffic at the same time. And this is how you DDoS yourself. Because in our case, we killed the interaction between application and database. There were some problems with queries to database, and we had to recover system for about 5 hours from this hit. And this was like, the system was perfectly designed, no hackers, no nothing. It just like that. Normal operations and very nice clients that don't hit you too hard. So we don't want to have a downtime. Why? First, we try to avoid this DDoS-like scenario. And second, maybe your business just simply wants you to stay online for all the time. Maybe you have like a very big headache just to announce a downtime. Maybe you have SLAs that you should fulfill, and each downtime is like a big hassle. You need to announce it like 3 days in advance and so on. Basically, the solution is to use a credential approach. In that case, we discovered there is no downtime, so either old or new Lambda version is available all the time. Does it mean that you always will have no downtime? No. This only concerns a particular case when you simply replace the code of your Lambda with new version. I give you a couple examples that we found where you can still have a downtime. For instance, you simply, for some reason, you renamed your Lambda handler function. I don't know why you would do that, but at some point we did, and again, it went offline because API tried to call some old name and so on. Second case, I remind that it's like for some time, I don't know if something changed recently. If you use Terraform and you tell your API gateway, okay, I want some throttling there. I don't want my DDoS happening ever. I put some throttling parameters in. And then you deploy a system, throttling parameters are set. Then you decide, okay, maybe I don't need that anymore. My system is better now. Yeah, I take the block out. So intuitively, you think that maybe throttling parameters will go away from API gateway, but no, they will be set to 0 instead, totally blocking your system permanently. So, so don't assume that any change you make in the system will be no downtime. You should be like really using hard facts if you make those conclusions. And we don't want to do a guesswork in that case. So how we approach this? We had a system that has to be available 24/7. So when we deploy to production, we have to know, should we make it a downtime? Should we announce our service break or not? So we did such an approach that in the system, which is like API gateway and app stack there, we deploy a new version of the system of infrastructure and code to test environment. And while we are doing that, CI/CD, which is indicated by GitHub icon, it also starts a load testing runner, a little program that executes the load to the API of the system. We have like a bunch of methods and we just hit them at a certain rate. And after the deployment is done, the same CI/CD asks the load testing runner, okay, was there any downtime on any methods? And if yes, then we report them to Slack, to developer channel, okay, there was a deployment, there was a downtime or something. And that's how we know. And after that, at least we have some hard facts that deployment will or will not have a downtime. So that's how I approach that. That's basically all I got to say. Thank you. Here's my LinkedIn. Feel free to connect.
All right. Thank you, Askar.